Hello everyone. Today I am going to discuss about IoT privacy, security and governance. Let's start with introduction. IERC Activity Chain 05, that means European Research Cluster, is a cross-project activity focused on making a valued contribution to IoT privacy, security and governance. Activity Chain 05 does not define government policies but focuses upon research. These three aspects are closely interlinked and we link these aspects to ethics. The essential four contributions of IoT are classified into privacy, data governance, cybersecurity, and ethics. Privacy. It is one of the main sensitive issues raised by IoT. We will see detail about privacy in further slides. Data governance. It means setting internal data policies that apply to how data is gathered, stored, processed, and disposed of. Cybersecurity. It is the practice of protecting IoT devices and ecosystem from cyber threats. Ethics. Ethics focuses on the honesty of a matter. The device manufacturers must accept accountability to protect the privacy of consumers. Let me discuss about IoT privacy. IoT privacy is the special consideration required to protect the information of individuals from exposure or being affected in the IoT environment. And also, privacy is one of the most sensitive areas in the context of IoT. In IoT, all objects are connected to the internet and they communicate with each other over the internet. Hence, the privacy issue is crucial. Utility will overpower privacy because there are some unique open challenges and opportunities arise in designing utility preserving privacy techniques in resource constrained IoT devices. Then we move to IoT security. IoT security is a practice that keeps your IoT system safe. It is the technology segment focused on safeguarding connected devices and networks in the Internet of Things. So, it is a challenging and important research area to construct security structure with the combination of control and information. IoT security tools protect from threats and breaches, then identify and monitor risks and can help to fix vulnerabilities. There are some risks in IoT security. Lack of computational capacity for efficient built-in security, that means lack of transaction processing capability of computer systems or data sensor. Then poor access control in IoT systems and lack of regular patches. Patches means resolution of bugs or vulnerabilities and updates due to limited budgets and technical limitations of IoT devices. Now we have finished IoT privacy and security. The final topic is IoT governance. IoT governance has been referred to as the development and application by governments. In this contribution, decision-making procedures takes place to shape the evolution and use of the internet. Then, if you think data governance is hard now, it's not just IoT. It's devices powered by artificial intelligence, machine learning and mobility. Uses of IoT governance. Governing bodies and engineers can use IoT to analyze the complex aspects of city planning and management. IoT simplifies various factors such as population growth, zoning, mapping, food supply, social services, and so on. The world's most valuable resource is no longer oil but data. So, safeguarding data is more important. It will be achieved by data governance. Architecture of IoT security governance. There are 6 phases. They are IoT security strategy, IoT processes, data strategy, monitoring and reporting, lifecycle management, best practices. Let me discuss by one. IoT security strategy. Its primary goals are to maintain the privacy of users and confidentiality of data. IoT processes. Once the data gets to the cloud, software processes it and then might decide to perform an action, such as sending an alert or automatically adjusting the sensors or devices without the need for the user. Data strategy. It is a long-term plan that defines the technology, processes, people, and rules required to manage an organization information assets, monitoring and reporting. It is the process of discovering, monitoring, and managing your connecting devices. Lifecycle management. There are four stages in IoT lifecycle. They are design, deployment, ongoing management, and decommissioning. And finally, best practices to follow. Stay updated, use encryption, automate security with antivirus software, and so on. The challenges we face in IoT security, privacy, and governance are governance and privacy concerns, security challenges, user privacy and data protection, authorization and access control, which means unauthorized users access the data without any permission. Then end-to-end security, which measures between IoT devices and internet hosts are equally important. Attacks on privacy and reduced safety for users. To overcome these challenges, we have to develop comprehensive technical strategy to address the complexity, define a reference architecture for their IoT solution, then develop required skills to design, develop and deploy the solution, design your IoT governance processes and policies. An IoT solution governance model should address these challenges. Then finally, conclusion. From the contribution to IoT research provided by IERC projects, there has questions of IoT governance, security and privacy. We know that IoT governance is one of the key remaining challenges. Hence, future research is required into efficient end-to-end security measures between IoT and the internet. Thank you.